This conference will now be recorded.
Okay, so we'll start off with a basic discussion of the recapitulation of the with the concept that we have had discussed, right? And from there we will kind of go deeper into the variables, and we'll try to understand like which are the key variables, what type of variables are important for the model for a PD model, what are the type of variables which are important for a LGD model, or what are the type of variables which are important for a EAD model. Right. So we'll be discussing it along those lines. So very quickly, we'll just have a recap. So we were in the last session we were talking about we reviewed very quickly the covariate creation process. We talked about the key steps of model design, and we also identified that seasoning analysis is a very important analysis in this particular case, right? So from there, the next set of things that we also looked into, or the next set of things that we kind of tried looking in over there was that how exactly or what exactly are the key set of variables that become important for a PD model. Right now, having talked about that, one of the key set of variables, so we saw that there are four broad groups of variables which we would like to use for developing a PD model. So what are those variables, right? So some of those, so we started talking about the most important group of variables, and we had classified the variables into the delinquency variables, the utilization variables, the purchase variables, balance variables, the consecutive increases or the consecutive change variables, so variable which measures the consecutive change in the variable, and finally we looked into the variable in the variables, right? So so for each of these variables, there are multiple variations that we look into. Like for delinquency variable, one very important variant of that particular variable is the percentage delinquent, right? So it talks about the percentage of the variable that is, or the percentage of value which are delinquent. Now, so the percentage of delinquency event which has happened in uh, the last 12 months. So that's a type of that variable. In the last 6 months, last 3 months. Now, percentage or rate of change of percentage delinquency between the last 12 months and the last 3 months. So by looking into these kind of changes or into these into the rate of the changes of these variables, you can actually make out how important a particular variable is. So that was one very important part that we had talked about. Now, apart from delinquency, now why is it that delinquency is such an important variable for a PD model? The Basel PD model that we are developing over here, the segments that we are talking about, whatever we are talking about over here. So this segment is something which is very, so this is something which is very detail. So this is something which is very behavioral in nature, right? So this PD model is nothing but a behavioral PD model. Now, if I'm talking about a behavioral PD model, one of the important things that we kind of get to know is that yes, this behavior. So this is a behavioral PD model, and when I say a behavioral PD model, what I mean is that it is so where the behavioral variables will be very important, right? Now, these are the broad groups of variables, and these are the bank endogenous variables. Now, you can, apart from the bank's endogenous variables, you can also have other variables like bureau variables. Now, when we started off talking about Basel, we saw that the data requirement for Basel clearly states that you can use bank internal information, or you can use bank external information, or you can use a mix of the two as one of the exercises, right? So you can use a mix of the two set of sources of information for developing your respective models, right? So this is something which is there. Now, from this particular point, one of the most important points which have So one of the most important points which we got to see was that that delinquency is an outright behavioral aspect of a model, right? Now there are different delinquency variable itself will have many such implications. Will have a deep implication on the target variable. Now the utilization patterns, right? Utilization patterns also play a very important role. Now, by looking into the utilization patterns, or rather changes in the utilization pattern, you can actually identify whether a particular model is, or you can actually identify whether a particular PD, a particular account is a risky account or not, right? So, so if in the neighborhood of, so basically, if it's a credit card product, in the neighborhood of default, the utilization of the borrower is expected to increase. So there is always a high chance that the utilization of the borrower would increase in the neighborhood of default. Because he's trying to go into default, or he sees that he's going into default, he's unable to pay, he's trying to utilize maximum possible credit. Now, if that borrower is a bad borrower, so this is something which becomes a very important trait. The second thing that comes out over here is the second thing that we generally talk about over here is the the number of times the delinquency has consistently increased or consistently decreased. So this is another set of, so this is another very important set, right? Now, the second thing that happens over here is we look into the different rates of change of the utilization. We look into the utilization at the snapshot. We look into the rate of change of the utilization, and this utilization variable will always give me a side of the risk. So basically, let's say you have two people, and coming up to you, don't know anything about them. You look into the utilization. The person with the higher utilization is someone who is more risky. So you can actually make that out from the utilization pattern. That is, the utilization variables are very important variables, but do not trust on utilization variables completely, because they can be deceptive, right? So they can be deceptive in nature. So what we need to do is, so what we need to do is we need to have an understanding of that what would be the other variables that we should use for model development, or for developing a typical PD model. Now, obviously, if it's utilization, the second side is the purchase variable. So purchase variable is something that we need to look into, and we have discussed that previously. So you have a delinquency variable, you have the utilization variable, you have the purchase variables. So the purchase, by looking into the purchase variables, you will be able to identify that what are the sources of the utilization, what exactly is the pattern of that utilization, right? Then similarly, then something, so there is something that we need to see. So obviously, yes, so another important source will be over here would be the balance variables. Now generally the balance variable and the utilization variable, they go hand in hand. So if we use all these variables together, then uh, it becomes difficult. Then you can end up with multicollinearity. But given that you are trying to develop a segmentation model, so you'll observe the splits at the end, and based on that you will take your decision. So so the next set of variables that we'll have would be balance variables, right? So what are the balance variables like? The balance variables are balances outstanding at cycle one. Then we'll talk about balances outstanding in current cycle, the second highest balance as a percentage of the highest balance. So how is it? What exactly is the highest balance? How has the highest balance changed over a period of time for this particular account, and so on? Right. So if you look into this, so obviously one very important set of variables that we need to understand over is the payment variable. the payment pattern, the rate at which the particular borrower is paying back the outstanding balance, right? So be it the delinquency, variable utilization, purchase, or payment, right? It is very important to understand the role of each of these accounts. Now, with payment and balance, we create the payment balance ratio. And then we look into the payment balance ratio as at the snapshot, the average payment balance ratio, the second highest payment balance ratio, the percentage of the second highest payment balance ratio respective to the present payment balance ratio, the trend, the average trend of the payment balance ratio, payment balance ratio last 3 months, last 6 months, last 12 months, and we create all sorts of variations of payment balance ratios as well. Because the payment balance ratio will give me an idea about the willingness of the borrower to pay back. So how it is not only about the fact that the borrower is paying back, it is also about the fact how consistently is that borrower paying it back. So that is something that we would have in place. The next part that we would have with us is the consecutive increases in the variables. Right. So it talks about the consecutive run of months where you have been delinquent greater than zero. So the continuous run of month you have been delinquent at a stretch, but you have not defaulted. Consecutive run of months with delinquency greater than one. Consecutive changes in the balances over last 12 months, constant change in purchases, constant changes in payments. So these are the broad set of variables that we would generally look into when we are trying to develop a segmentation driven probability of default model. Now the question is that how is this segmentation done? So this segmentation is not only done very simply as a business segment that we talk about when we develop scorecards, but this talks about but this particular segmentation framework has multiple layers of segmentation, right? And there are three broad layers of segmentation that we generally talk about, right? So there are three layers of segmentation. Three layers of segments. The first set of segmentation is the regulatory segmentation. So where I'm dividing the account into two parts. One is a QRRE and the other is a non-QRRE. This is the regulatory segment. Right. Now, the next that I talk about is the risk-based segmentation. The risk-based segment. And the third that we talk about is the statistical segmentation. Is statistical segments. When I talk about statistical segmentation, so the statistical segmentation that we will actually develop over here will be done using decision trees. we're done using decision trees. So what is a decision? So we'll talk about decision tree later when we go to statistical segmentation. So now the question that comes out over here is that what exactly are the regulatory segments and the risk-based segments? So we have an Excel sheet around this. So this is a typical segmentation based probability of default model. And this is how exactly the model would look like. So you would have ultimate at the end of the day, you would have some segments, you have some pool IDs, pools of loans having certain characteristics. You will have the months, and you will have the accounts, personal accounts in segments, and you will have some set of risks. Okay, so we'll talk about each of these segments and how these segments are kind of working and so on. This okay. So over here, there are two questions that we need to address. Number one, how are the segments created? How are the segments at different levels created? So that is something that we would want to understand. Okay. So the first thing is the first level of segmentation. So as you can see in this model, so this was one of the models which I had developed historically. So I'll show you how the segmentation model has been built, what are the underlying logics, and how the splits have been done. Right. So over here, the first level of segmentation that we have done is a regulatory segmentation, and it's still specified. The second set of segmentation that I have done over here is the level 2, the risk-based segmentation, and level 3 and level 4 that I have shown over here is based on statistical segmentation. Right. Now, some of this level 3 segmentation is still intuitive. 4 have 4, and generally fifth segment are generally kind of statistical in nature, the next 2 3 levels. So I'm just kind of just to show this a summary, I have divided this into these parts. Now there are a few things that we need to keep in mind. Right? So now the question is that how is it that these segmentation will be done, and what are the important checks that I need to do in order to actually ensure that the model that I have built over here, right, the model that I have built is actually stable. So the segments are actually correct and that they are making sense, right? And how do I quantify the probability of default in my data from this particular segmentation that I have obtained? So this is something that we want to understand. So first what we have is the whole portfolio. Right? So I'll put this as the probability of default for the QRRE portfolio. Number of accounts is like black. Calculate. Let's say right.
How do we decided this bad rate 3.1%?
Sorry.
This bad rate, how does like it's a are you assuming hypothetically or somewhat you have
Yeah. So
calculated?
so bad rate is a typical definition of a total number of bads divided by the total number of accounts. So which I'm putting it at 3.1%, which was the bad rate for that portfolio. So a typical
So
credit card portfolio is expected to have a bad rate of around 3 to 5%.
so in credit card portfolio in that data where we do the model, so do we have the bad rates as a column like bad this is the number of customer who has been defaulted has not paid back, or we have to derive
Obviously,
the
we'll
bad
have the
rates on.
observed. Yeah, yeah. Obviously, we'll have the observed good and the bads for every month.
Okay.
So in any data, you will always have the 1 0 column.
Hmm.
So that
And then we
those
have
are
to
your
test,
observed goods and bads.
okay, right. Then we have to test if it is really bad or if it's really good, right?
No, no, you are not testing whether it's really good or really bad. So those are observed defaults. Now you are using your model to predict. So, so
Okay.
every account that you have in your data will fall in any one of these 10 segments, right? So you have created segments like that. So whatever characteristics they will satisfy, they will either be mapped to this from this pool to this pool in any one of these pools. So whichever pool it falls, you assign that pool PD to that account. So that becomes the estimated probability corresponding to that. I'm coming to that. We are coming to that calculation.
Do we have the data for this from you have
No,
built this?
no. This is a real time credit card data which I had, uh, and I had developed this model. So I had the report back with me. So that is something that I'm kind of showing it to you. I don't have that real data. I mean, even if I have, I cannot share that data with you. So I made a summary of a smaller version of that data from that credit card data. So which is like a 6 months data. So that data is already up there on the drive. So the number of
Okay.
accounts over there is limited to 50,000.
All right.
Okay. So the first level of segmentation that happens is, so whenever you are doing uh, so whichever data you are like model you're working on, right? So if it's a retail portfolio, and depending on that, so now if you separately have the QRRE data in one file, that's okay. But generally, when you have the entire retail portfolio, right? So your overall portfolio is your retail portfolio. So the first level of segmentation that you do over here is you do a QRRE versus a non-QRRE. So when you have the whole data in in your so when you have the whole retail portfolio and you're developing it for other retail, it becomes other retail and QRRE. So QRRE remains unchanged, and then you develop it around other retail if that's another. If it's a QRRE, given that it's a QRRE, so over here we'll be expanding on the QRRE and others go down there. So in this portfolio, I'm saying that so the portfolio split between QRRE and the others was around 75-25. So I put it at 74 and 26. Now over here, the the next segment that we have over here is the qualifying revolving retail exposure. So now this qualifying revolving retail exposure will be broken down into the next segments, into the next parts. Now the second level of segmentation that you want, right? So let's say you have a whole credit card portfolio, right? And think about it that you don't have access to any other information, right? So how is it that you are going to judge two people who have your credit card with them and they are spending on their credit card and you need to develop a model for them and you don't have anything else? So what is that basic information that you need to look into? The basic information that you look into is whether the person is paying money back to you or not in time. So is that account delinquent, non-delinquent, or whether that account is inactive? Now, again within inactive, we look into whether the account is inactive for less than 6 months, more than 6 months. So that part is there. But generally, accounts which are inactive for less than equal to 6 months are not considered to be inactive. For a credit card portfolio, the typical behavior is to consider those accounts which are greater than equal to 6 months as inactive, right? So the account is inactive for so if an account has been inactive at greater than equal to 6 months, then that account is actually then that segment is defined as, or that is defined as an inactive account. So that's the inactive definition that you use. If an account has not been having any transaction on a credit card for more than 6 months in a given performance, then that account is inactive in the performance. If, as on the snapshot, it has not been operating, it has not been using its card for the last 6 months, then that account, as on the snapshot, is inactive. However, inactive accounts are mostly looked into. So I'm looking into that account as an inactive account in the snapshot, right? Or yeah. So over here, I have, so basically I just want to look into the fact that whether the part, so first of all, my base is divided into active and inactive space. For the inactive, I don't have too much of like this to take, because that segment is inactive. I need to look into some other matrices for that. So we come to that. Now, the more important base is that active base. Now, within that active base, there is an active non-delinquent base and there is a delinquent base. So accounts who are using my credit, now the riskiness from them can be easily identified in terms of the willingness of the borrower to pay back or on the regularity of the borrower to pay back. So if the borrower is a delinquent borrower, right? If the borrower is a delinquent borrower, then it means that the borrower, as on the snapshot, the account has missed out on a payment, whereas the non-delinquent account has not missed out. So what it essentially means is, that the active account is inherently less risky than the delinquent account, right? The inactive accounts are not as risky as delinquent based, but they are So there is always a kind of non-determinism around them. So if my account is not using my credit card, I have to, in order to assess his behavior, I need to look into external sources. Why is he not using his credit card? It is because it is his behavior not to use, or because he is already in a circle of credit. That is why he has kind of stopped using my credit card. Why has he stopped using that? So from there, when I go to answer that why, I can split up the riskiness between the inactive accounts. So if so basically, for any segment like as an inactive segment, what do you want? Or if they have missed out one payment in the last 12 months. So if my population now there are two considerations over here. Now generally, when you have a through the cycle data, right? When you have a through the cycle data and you have a data over a large vintage of time, right? Never default versus all at least 1 to 2 this is clearly see that that account was performing for long over a long because of some reason he has missed out the payment. So that right. So for need not further split this basis value. So the next think about it, there are right. So now the part on my books of liability. So this guy should be having a relatively lower bad rate. Accounts which lower month on books, or which have a higher month on books, less compared to accounts who have this. So now what is the importance of this month on books? Now month on very intuitive segmentation for a probability of segmenting it basically. So if even if you do not do segmentation, you run a decision. This is because the age of a model of is significantly bigger, and that is why that the thing happens at the point where your seasoning curve is seen to taper off. So if these two results reconcile, you know that is the time when your account is seasoning. So if you take the active base of accounts and you run the decision tree, that split should happen at the point where your seasoning curve is actually tapering off. So that is a check for assessing the seasoning of your portfolio. That what is that point at which my portfolio generally tends to season off. Now after you have done this, after this has been done, now there are other segmentation possibilities as well. So what you have done is you have kind of split it according to the month on months. Now if you are not developing a segmentation model and your three broad segments within QRRE are active, delinquent and inactive, and you are developing a logistic regression model, you will see that the most significant variable in your data will be your month on months. So in a behavior scorecard or in a behavioral PD model, the month on books variable is a very important variable for the non-delinquent segment. So the first, if it's a segmentation model, the first split must happen there. And if it's a logistic regression model, that month on books will be the topmost variable. It will have the highest world chi-square with the overall with the highest percentage, the highest relative distribution in terms of the world chi-square. That is another important observation, right? So this is the way you can actually validate whether the splits have happened at the correct part. And if it's a delinquent segment, there are two important variables where you can have the first flip. One of the important variable is the utilization variable. So given two delinquent person, the one with the higher utilization is always the more risky. The second variable is where you can also have status of revolver versus a transactor, right? So if there are two delinquent people, you know the accounts which are revolving, which have been revolving, are more riskier compared to the account which are the transactors. So the transactors are those accounts who use the money in a cycle and pay back the entire amount. They do not keep any amount pending, so no interest is charged on those accounts. So they are the safest accounts of the banks for the banks, but they don't earn any business either. Accounts which are CD0 and revolver, that is, they pay something like a minimum balance or something more than the minimum balance and revolve on the remaining amount, are relatively riskier than the transactors, but they are the ones who actually earn the business to the bank. And the third are the revolvers with CD1 plus, CD1 or CD1 plus. So these are the accounts who are delinquent revolvers. Now, among the revolvers, if you are a delinquent revolver, then you are in for a trouble. So basically, with the delinquent segment is can be further sub-segmented into revolvers and transactors. And within the revolvers, you can distinguish them according to their utilization. So that will add out another level of segmentation if required. So that's a possible segmentation structure, right? So whenever you have two delinquent people, right? So the one with the higher utilization you would always know are the more riskier, right? Now the question is that let's say I have two people who have. Now let's go back to the active account segment. So the split has happened at 12 months. Now let's say I have two people who have QRRE products who are active non-delinquent till now, have never been delinquent. Both of them are have month on those greater than 12. Now these two people are coming out with. Now what do I want to know about these people? So how is it that I can distinguish from what percentage has that capability gone down. If it is less than 0.7, then it's relatively lower risk. If it's greater than equal to 0.7, then that's a relatively higher risk. So what we are trying to do over here is we are trying to. So if you think about it, within the non-active, non-delinquent segment and at the seasoned non-delinquent segment, people who have gone through a higher decline in their payment balance ratio are relatively more risky than people who have not gone through a delinquent, such a delinquency drop. I mean, such a drop in the payment balance ratio. So if you observe the segments make intuitive sense. So one of the first and the most important thing that you need to keep in mind when you are building a segment is that that segment must make a intuitive sense. Without that intuition, if you cannot actually explain that segment, then that segment is as good as not being there, right? So whenever your segmentations are being done, so you'll develop two, three levels of statistical segments and one, two levels of business segments or risk-based segments, right? So at each stage, apart from statistical checks, the intuition must be there. So you should always ensure that the segments that you are building, right, must make sense, and that must make business sense actually, right? Without that, you cannot get to a segment. I'm coming to the statistical checks of the segment in a while. So let's first look into the explanation of the delinquent segment. In this delinquent segment, now there are, so I have the delinquency base. Now, how do I decide or how do I explain the riskiness between these? So I'm saying that accounts who have a lower utilization are have a higher utilization are more risky, and accounts which have low utilization relatively less risky. So for the delinquent, so now if I think about two delinquent people, I can look into the delinquency and I can totally say that yes, this is what the reason is. Now for those accounts which have lower utilization, right? Now the question is that for accounts which are delinquent as on the snapshot, but have relatively lower value of utilization, like lower than the cutoff. So how do I distinguish two people over there? So obviously, I would look into the times they were delinquent for more than 3 consecutive months, or let's say less than equal to 3 consecutive months, right? So if that, so depending on the percentage of the time or the frequency of them going delinquent. So from a low, so let's say there are two accounts whose utilization are less than 85%, right? Now for these accounts, how do I decide? Now the account which has been more frequently being delinquent and coming back, delinquent coming back, and that has been more volatile out of these two are will be the more riskier ones. On the other hand, for accounts which have had a very high utilization, I would always consider those accounts to be less risky, which are which have been paying back more. So accounts whose payment balance ratio has been higher for this higher utilization is considered to be less risky. So the next split for this utilization greater than this is happening at a payment balance ratio, whereas for the one where the utilization is less than 0.85, the split is happening at the level 4. I mean, the level 4 segmentation is happening at the delinquency variable. Now the reason is now the question is that can't this be vice versa? So can't you have a payment balance ratio splitting there and delinquency kind of splitting here? Now, even if that was the case, could that have been intuitive? Now let's try to look into that. So let's say for there are two delinquent accounts with low utilization. So they have not utilized or the utilization has not been very high in terms of the cutoff that has been there. So what would the payment balance ratio kind of tell us about that? So if I use payment balance ratio at that case where the utilization is less than 1 or where the utilization is low, so payment balance ratio or the payment that he is making is not that critical a factor. So it's obviously a safety factor that, but payment balance ratio, but the rate at which you are paying actually becomes very important when you have a very high utilization. So let's say my utilization is 10% or 15%, right? Now it doesn't really matter that like how much am I paying back, because my utilization itself is very low. But my utilization is low and I have been delinquent. That means I missed out a payment. So that's where my worry comes out that okay, even if the utilization is low now, let me look into his delinquency patterns, because if he has had a very clear delinquency trend, then he is obviously more risky than a person whose delinquency trend is relatively lower. But when the utilization has gone up over a certain limit, and so that's where the payment balance ratio becomes very important. So how much of the payment balance that you are paying back, because the payment balance ratio is expected to drop at a higher level of utilization, because when you utilize a lot of credit, you don't want to pay it back then. So it becomes difficult to pay that credit back. So that's why that payment balance ratio is an important variable when utilization has become higher. At a low level of utilization, the payment balance ratio is always high for most of the year. So because after a level of utilization, you realize that it is very difficult for me to pay back. Right. So that's something that you need to take care of.
Tanmay, hello.
Okay, fine. Okay, I missed out your messages over here. So is it audible now? I did not see that message. Can you hear me now, everyone?
Yeah. Tanmay, one question.
Tell me.
These values, MOB is less than 12 and equal to 12, and these utilization less than 0.85. Are these some standard values or like some
No,
cutoff?
they come from,
Uh,
so these are the statistical level of segmentation. So this is where statistical segmentation happens. I'll explain decision tree and how these splits happen. I'll come to it. So I'm just first explaining the segments and how they are and how exactly can you interpret them, how do you validate them, and so on. Then I'll come to the decision tree. I'll talk about these statistical level of segments in details. I'll come to it. So these splits, so basically the point where the decision tree splits that variable, right? So you get a split by a variable and by a value. So that is that cutoff value. But generally for MOB, the split generally happens at a 12 months to 13 months for a retail portfolio. And that's, so that is by behavior something standard. And when you do a seasoning analysis also, you will see that papers of at that. So MOB greater than equal to 12 and less than 12 is standard split. But for the others, generally what happens is the splits are come from the like they come from the chi-square values of the decision tree. So when you split it, the split happens by a chi-square or by the Gini. So I'll come to that. I'll talk about decision trees in separate. But first, let's try to get an idea about the segments and the characteristics and how to interpret the segments and how to validate them and everything. Then I'll talk about decision trees separately. I'll come to your question. So any other questions? Perfect. Fine. So now let's come to the third part, which is the set of inactive accounts. Now, if you have a set of inactive accounts, what will happen is as I was saying, now let's say the account is inactive. So it has not actually used anything in my mind. So presently it has not used anything. Now what I'm trying to look into is that is this account or has this account historically been something which is or so has this account been historically has this account been something which is not so has this account historically been inactive, right? So over here, I'm looking into so this account is kind of greater for the last 6 months or more. It is inactive. It is not using so it has not used the balances. So what I do is so when the decision tree when the variable is passed through there. So when I'm trying to further segment the variable, I see a segment happening at maximum balance in 12. Now, assuming that this is the variable which has been at which the variable has been split. Now the question is that is this a viable split? Now I am looking into the maximum balance in the last 12 months. So is that less than 75 or has it been more than $75? So that split happens at 75. That's a statistical result. Now, as modelers, we need to interpret that given the credit card product and given that the segment is an inactive segment, is it possible for this split to be interpreted or can I use this split as a separate split, right? So, intuitively, is this segment correct? Now, obviously, if I don't have a very recent information, I look into a historic, a long run, longer historic information. So I say I look into the maximum balance in 12 months, which is less than 75. Right. Similarly, I look into maximum balance in 12 months greater than equal to 70. So I'm trying to check whether the historical maximum balances that I have seen is around a specific split or not, right? So if the maximum balance is less than 75, so it means it does not use more than $75. So that account, so it means this account hardly uses anything. So it means that the risk from this account is not very high because presently it is inactive and even when it has used in the last 12 months, it has been less than $75. So I know that there is not much of a risk and hence this is less risky. But this is less risky compared to the account which is which has been kind of so it is less risky than the delinquent segment but more risky compared to the active segments, right? So over there, I would actually expect. So obviously, the riskiness from this segment will be relatively higher, lower compared to the delinquent segment. So over here, when I talk about this, I see that the maximum balance in the 12 segment is like so in 12 months less than 75. So it means that in the last 12 months, whatever the account has used, the maximum balance is less than 75. So he is not a very ardent user of the card. So from behavioral risk, this borrower is not much of a threat for me. But the accounts which are inactive now, but in the last 12 months have had higher balances, means that they have the tendency to use the balance, right? But as of now, they have not used it. So if you think about the fact that let's say there are two inactive borrowers coming in front of me, are there with me, and I want to assess that who is more risky, who is less risky. So what I'll do is I'll say that yeah. So what I'm if there are two inactive accounts with me, I would just look. But the balance for those accounts in the last 12 months, which has been more than 75, is something that I will do. Now I want to understand that out of these two borrowers who have or what has their sources been, right? So people whose balances are very high, if you want to split them, you need to do it by the purchases. Because if the purchases are low, right? If the purchases are low, you know that that particular borrower also has withdrawn cash. And if their purchases are higher, then you know that they may or and given that they have a cash withdrawal facility, they may be risky. However, however, for that the purchase segment has to be further divided by or segmented by cash withdrawal. But over here we are not doing that. We're just looking into the purchases. Now, the accounts for whom the average purchases is less than 0.97 are relatively less riskier, and for whom the average purchases relative to the average balance is greater than 97. So whose purchases has been like 97%. If the average purchases the last 12 months is like 97% of the average balance in the last 12 months, then you know that person actually has had a very high purchase or has had made huge purchases. So, so those borrowers are much riskier. Now it may be, people. It may be that in one of an instance the person has made a high purchase, but after that the average purchase, so the purchase around have been much lower. So as a result, that average purchase in the last 12 months will go down, right? But on the other hand, if a person has consistently made higher purchases, so there are higher purchases will be much higher. So if this segment will help me decide or divide those people who have made one of a purchase a huge value, high value purchases one of an instant versus those people who on an average make heavy purchases, right? So people who are consistently high purchasers will be differentiated from those accounts who have made no purchases at all or who have made very low purchases. So this is something which we need to look in, right? So over here, this segment is also a intuitive segment. So the first check that or any segment after you have developed a segment or after you have run through a decision tree or you have got through to a segment, one thing that you always need to keep in mind is that a segment is something which must be intuitive in nature, right? And the rank ordering of the segment must be maintained. So basically, accounts which have higher utilization and accounts which have lower utilization on an average must have lower probability of default than accounts which have higher utilization, right? So that must be maintained. Now the question is, I have developed these segments. Now there are multiple levels of segmentation, and I have divided and I have created 10 segments. Right? Now, one of the important question is, how do I know that my segment, first of all, my segment is stable, and the second is that these segments are correct. I need to validate. And the second I need to see is that how good is this model. Now, as how good the model is, I need to divide it. I need to look into it from different perspectives. I need to assess it in terms of accuracy. I need to assess it in terms of stability, and I need to assess it in terms of discriminatory capacity. On the other hand, I need to assess a segment basis, their ability to distinguish risk and their stability in terms of the rank ordering. So over here, there are a few important things that we need to talk about, right? So the first is I need to types. This is something just one. So this is the model validation framework. Now, this model validation framework talks about the fact that how is it that you would assess, or how is it that you would kind of assess, number one, the segments, and how is it that you would kind of monitor the performance of the model, right? So obviously, as you can see, the three major model validation metrics, so the model performance matrices are accuracy, discriminatory capacity, and stability. So in this sheet, we also talk about the data. We talk about the data check, data preparation. So these are a part of the development exercise that we have already talked about, right? Now after this, the next thing that comes to us is to understand how to assess the model. We'll talk about three things. We'll talk about, number one, how to assess the model and how to assess the segments. Okay. And then how do you kind of, yeah, so how to calculate the PD at the segment level and so on. So one thing, so the next question that we need to address over here is that how do I validate the segments, or how do I know that the segments have been correctly created? If I have a look into this, so okay, so before I go, yeah, So how do I know that the segment has been correctly? If the segments have been correctly created, then the segments should, number one, have clear risk distinction. So the average bad rate across the two segments must be significantly different. So, for example, if I have two pools created over here, this pool and this pool, right, and I have this PD and this PD, so then that pool, this the mean difference between these two pools must be statistically significantly different over a period of time. So if I plot the bad rates across, and if I calculate the bad rates across the periods, and then if I try to see whether the difference is statistically significant or not, I must get statistically significantly different mean difference, right? And the test that we do, the heterogeneity test that we do over here is the ANOVA test. So using that ANOVA, what we do is we try to assess how statistically significant the variable was, or the mean difference is. Now the second thing that I do over here is I look into the rank ordering. So basically, if I take the historical data, the data that I'm using for parcel model development, if I use an entire time series and if I plot the bad rates of this segment that I have created, let's say of this segment and this segment, this pool and this pool, right? And if this particular pool is more riskier than this pool, then at each point of time, this pool must always lie above, the bad rate from this pool must lie above the bad rate from this particular pool. So this is where the second test of this segment comes in. So what are the two tests that we do in order to assess this mean difference is statistically significant? What we do is we say, fair enough, this is what your segmentation is. These are the two segments that we have in that's under question. And in each of these two segments, I have uh, so in each of these segments, the respective address are this. And when I plot them over a period of time, I always see that the more risky segment is always lying, the bad rate of the more risky segment is always lying above the bad rate of the low risk segment, and that kind of continues over a period of time, right? So that continues over a period of time, and this will give us that particular insight. So these are the mean difference test and the rank ordering tests are the two tests which we use to check whether the segment has been correctly created, right? So segment validation tests. So I'll just break down with columns. So segment validation test. Okay, now I have the segment validation test done in the next column. So if you come over here, to create a portfolio. So over here, when I'm trying to look into the data, so it's the two-piece test. This is the concept of NOVA, is the analysis of variance. So in the ANOVA, what we are trying to do is we have multiple categories. So we have a multiple categories. So there are 10 segments. So for each of the 10 segments over the entire and we'll have all your bad rates. So you'll have the bad rate distribution, and now you have to compare the across the group variance and within the group variance to compute your statistic, or if your F is statistically significant, then the mean difference is significant, else it is not. Yeah, no analysis of variance, and this is the one-way analysis because I'm not looking into any interaction effect. So all this is described in the analytics, predictive modeling, and okay. So after the heterogeneity test, the second test is the rank ordering test. Now over here, what we want to know, so what is the rank ordering test over here? The rank ordering test is that the risky segment is always more risky than the less risky. That is, in no point of time there will be a case where the risky segment will have less lower bad rate than the more risky segment. So that is the next important topic that so that's the second test that we generally do to assess the stability of the segments. And once the segments are completed, the next thing that we need to know over here is we need to understand how statistically significant or how it is that the model is performing. So when I look into the model has is kind of divided in, or is kind of explained through the strength and the discriminatory capacity, right, which is KS and Gini. Now the robustness of the model is kind of assessed in terms of deterioration in the model performance from the development, how much has the Gini gone down in the validation and the out of time validation data. So that percentage fall is kind of something that we need to address. The second is the accuracy check, comparing the expected and the actual default rates, and then stability measures like the population stability index. So over here, all the calculations are done, right? So we can see how exactly the Gini is calculated, how the Gini looks like, the case and Gini is calculated, K statistic looks like, the model validation, so how that happens, how is deterioration calculated, how is the population stability index calculated, and whether it's good or bad. So you can have a look into this entire Excel sheet, right? So it will kind of give you an idea about what are the methods through which the model is validated, what are the formulas. So if you click, this is an absolute automated sheet. So if you come back and if you click on these Excel sheets, you'll get to see what the exact formula that has been used over here to complete the case and the Gini, right? Also given a design distribution, you can find out all these, you can calculate all the values, and and over here like we have. So this is something we will generally logistic regression model. Not bother about that. So I just created this so that you can compare a logistic regression output to the segmentation model. So now nothing more than that. Right. So this is just an order way we have already explored this in the application scorecards. So these are the measures, right? And the entire validation framework is provided over here. So, so this is how a typical segmentation model is built and it is assessed, right? So we discussed it for the PD model only. So over here you have the PD, LGD, and the EAD model documented. So if you go down, there are the PD, the LGD, and the EAD segments as well. So the EAD segment is fine. So just have a look into the EAD and the LGD segments. We will discuss these two models in tomorrow's session. Just put it over here. You have the exposure at default and the LGD. So you kind of get an idea about how what kind of segments are created. So we'll talk about these segments in tomorrow's session. I'm sending over this Excel sheet to you, right? Thanks.